Okay, so in this example, we're given two linear equations. And what we want to do is we want to solve this. So we need to find the value of x and y that's true for both of them. We're going to use a graphing strategy. So what do you notice about the first equation? What form is it written in? It's written in y-intercept form. So can you tell me the slope of this line?
2x.
The slope refers to, thank you, just the coefficient of x, just the number in front of x. So the slope is 2. If I want to write this as a fraction, what can I put it over? 1. So I know when I go to graph this, the rise is 2, the run is 1, and is it a positive or negative slope? So how is it going to look? Rise to the right. It's going to look something like that. What is the y-intercept of this equation? Good. Positive 1. Okay, so the first equation is easy because it's already written in slope-intercept form. Equation 2, is this written in slope-intercept form?
No.
So what do we need to isolate?
Minus x.
We need to isolate y. So what are we going to do with this positive 1x? Good, becomes negative. To get rid of it, we subtract 1x. So what do I have to do to the right side?
Minus an x.
Good, so we are left with 2y equals, did I do anything to negative 8?
No.
So that stays on the right side as negative 8, and I'm subtracting 1x, or just x. Does it matter if I put a 1 in front of it?
No.
No. Okay, is this in slope-intercept form?
No.
Did I isolate y?
No.
What do I need to do to isolate y? Good, divide everything by 2. Y equals, what's negative 8 divided by 2? We're going to leave the rest of it as a fraction because that's negative 1 over 2x. Now that it's in slope-intercept form, which part of the equation represents the slope? The coefficient of x, right? Which is negative 1 over 2. So the slope equals negative 1 over 2. And what's the y-intercept? Negative 4. Good. The y-intercept is the constant term. It's the term without the variable. Okay? In our first graph, we know the y-intercept is 1. So where's that point located on the graph? 0, 1. Let's say this, I'm counting by ones, okay? This is my x and this is my y. And I know that the slope is what? Negative or positive? So I'm rising. Slope is equal to rise over run. We're rising 2. So I'm going to count in yellow so you can see. 1, 2 squares. And how many squares do I run? 1 to the right, okay? So the next point is located right here. I'm gonna keep going. I'm gonna extend my graph. Rise 2, run 1, and draw the point. Again, rise 2, yikes. Run 1, draw the point there. Okay, so I'm gonna connect the points of what I've drawn so far, and we can still extend it if we need to. Let's plot the second line in pink. What's the y-intercept for the second line? Negative 4. So where would I plot that on a graph? 0 and then 1 down 4. 1, 2, 3, 4. We can rise 1 down and 2 to the right. Because I know it has a negative slope, the line has to fall to the right. But if I keep falling to the right,
Hi, Derek.
does it look like these two lines are going to intersect somewhere over here? It does?
No.
So what should I do with my pink line? Go up 1 and left or right? Left 2. Up 1, left 2 is here. Up 1, left 2. Up 1, left 2. I'm going to keep extending it. What should I do? I want to extend my blue line because it looks like these two lines are going to intersect somewhere around here, right?
You are 100% correct.
So what was the rise for the blue line? I can move down 2, right, from the blue line, and am I going to go left or right one?
Left.
Left, good. So the next point is here, down 2 over 1, down 2 over 1.
Miss, you are 100%
Yes.
correct, miss.
Okay, so we're going to look at the graph, and I can see that the 2 lines intersect right here. What is that point? What is the coordinate of that point where they intersect?
-2.
1, 2, 1, 2, 3. -2, -3. That means that x is -2 and y is -3, and that is true for both equations. We're going to check to see if that is true, okay? Okay, so we have our solution, which is -2, -3, and I want to know, does this solution satisfy both of the equations? So is this, if I plug in the x value and if I plug in the y value, for both of them, we're going to see if it works, if it balances. So instead of writing y, what's the value of y that we found? Good. -3. So -3 equals 2. What operation is 2x? Multiply, good. And the value of x was -2, good. Plus 1. So let's keep our left side and our right side separate. We have -3, and then we have 2 times -2 is what? -4 plus 1. Let's simplify the right side. What's -4 plus 1? -3. Does it work? Left side is equal to the right side, so we're happy. It balances. It's true for the first equation, so this one worked. Let's check to see if it's true for the second equation. So you're going to follow the same steps. Okay, so checking the second equation, when I plug in x and y, it also balances. Okay, the left side is equal to the right side, which means that this point is a point that is on both of these lines. So therefore, that's when both of these lines intersect. They have the same value at -2 and -3.
Made with Doodlecast Pro.